In this video, we will discuss the displacement time graphs for bodies moving with uniform acceleration. We know that displacement is given by s is equal to ut plus half at square. And if I consider bodies whose initial velocity is 0, then the equation will take the form s is equal to half at squared. And since we are considering objects moving with uniform acceleration, a is constant, this would imply that s is proportional to t square. And therefore, for this, if I plot a st graph, since s is proportional to t squared, we will create a curve like this. As you can see over here, the slope of the curve is increasing. The graph is initially tending towards being horizontal and becoming vertical. So slope of the graph is increasing. That is because the velocity is increasing. Or I should say, since the velocity is increasing, the slope is increasing. As you can see, if I take displacement for 1 second over here, the corresponding displacement will get as a small displacement. Whereas if I take 1 second later on, the displacement is much larger. This would also indicate that the velocity is increasing. So slope is increasing, velocity is increasing. The next question that I have is, if the ST graph is plotted like this, or if somebody tells us that the ST graph of an object has a shape like this, is this a valid ST graph? Is this acceptable? Let us think about it. In fact, let me introduce two more possibilities. The ST graph with a curve like this, and ST graph with a curve like this. So do these graphs represent a body moving with uniform acceleration? The answer is yes. All these graphs represent bodies moving with uniform acceleration. So then let us try to understand what is the difference between the four cases. Let us name the graphs. Let us call this graph 1, 2, 3 and graph number 4. In this graph, we can see that the slope of the graph is decreasing. The graph is from vertical is becoming horizontal. So slope is decreasing, and therefore I will say velocity is decreasing in this case. If I look at this graph, the graph is initially horizontal and becoming vertical. So slope of the graph is increasing, and therefore we will say that the velocity is increasing. In this case, slope is from vertical to horizontal. Slope is decreasing, so we will say the velocity is decreasing. Thus, we see that in graph number 1 and 3, the velocity is increasing, whereas in graph number 2 and 4, the velocity is decreasing. If that is the case, what is the similarity or what is the difference between the two graphs? So let us compare graph number 1 and 3, because in both cases, the velocity is increasing. So let us look at graph 1 and 3. In graph 1, we see that the slope is increasing. In graph 3 also the slope is increasing because it's becoming vertical. But here, as time goes by, s is increasing because the graph is going up. Whereas here, as time goes by, the graph is going down. That means displacement is decreasing. So therefore, we can say here that the object, or before that, let us write displacement is increasing. Therefore, the object is going away from the reference point or origin. Whereas for graph number 3, s is decreasing. Graph is going down. S is there on the y-axis. Graph is going down, so s is decreasing. That means the object is moving towards the origin. Towards. Likewise, in this case, the graph is going up, displacement is increasing. So S is increasing, object is going away from O. And here S is decreasing, graph is going down. So towards O. So this is the difference between the four graphs. Mind you, I have taken a very simple case, meaning that I have taken a case of positive displacement. As you can see over here, I have plotted this graph in the first quadrant, meaning that we have taken only positive displacement. So if, let us say, this is the path on which the object is moving, and let us say this is the reference point 0. This is the positive side, this is negative. Since we have plotted only positive displacement, so we will try to understand these four motions with reference to the positive side from O. So in this case, in the first case, it is moving away from O with increasing velocity. That means it is going in this direction with increasing velocity. So this is graph number 1 with increasing velocity. Let me put the values of velocity. So velocity is, let us say, 10 meters per second, and it becomes 20 meters per second. This is for graph number 1. For graph number 2, S is increasing away from O but decreasing velocity. So it is going away from O with decreasing velocity. That means the velocity here is, let us say, 40 meters per second, and it is becoming less, so it might be 30 meters per second. Of course, I am taking arbitrary values. In this case, it's moving towards O, so the motion would be in this direction. Please do not read into the length of the arrows. I am just trying the random length of the arrow. S is, it is just showing the direction, so it is moving towards O in this direction, and velocity is increasing. So with 10 meters per second, and this could be 30 meters per second. So it is moving with increasing velocity over here. And in the last case, again moving in this direction towards O with decreasing velocity. So let us say 5 meters per second, and the velocity is becoming 2 meters per second. So this is the interpretation of these four graphs. All the four graphs represent the motion of a body with uniform acceleration.